Hello, I'm David Valdés, and today I wanted to talk to you about solving quadratic equations by factoring. And the first thing that we should discuss is the zero product principle. Zero product, or we could call it property. More generally, there is a zero product theorem. We'll just call it the zero product property, and what that is the following. Whenever you're multiplying a couple items, let's just say A times B, and you get 0, then this tells you something about A or something about B. No matter what A is, if B is 0, then A times B will equal 0. No matter what B is, if A is 0, then 0 times B is 0, and you still get 0. So you can say that it must be true if A times B is 0 that A equals 0 or B equals 0. And mathematically, when we say or, we're talking about an inclusive or. So it's A equals 0 or B equals 0 or both, as opposed to an exclusive or, which is more typical to English phrases. So again, when you're talking mathematics, this is an inclusive or. So it's A is 0 or B is 0 or both. And we always take the case that both are equal to 0. Okay. So let me give you an example of using the zero product property in solving an equation. Suppose we had x times x minus 2 equals 0. Then in this case, we have two factors. The first factor is the first factor is x, and so we can equate that to a here. The second factor is this binomial factor, x minus 2, which we can relate to this b up here. So we can say, well, it must be true that x is 0 or x minus 2 is 0. Now, if x is 0, this clearly is a solution to this equation, because if I put 0 right there, it doesn't matter what this guy comes out to. 0 times this stuff is 0, right? From the second one, x minus 2 equals 0, I can take a quick step to solve this other equation. Notice how I took one equation and broke it down into two equations. This gives me x equals 2. And what we can see with x equals 2 is if I put 2 right here, 2 minus 2 is 0, and that makes the b factor equal to 0. This would be a 2 out here times 0 altogether here equals 0. So there are two solutions to the equation shown. The two solutions are x equals 2 and x equals 0. This will apply to quadratic equations when we start to factor. What we're going to try to do is always end up with this case using the zero product property. We're always going to try to factor so that we have one factor times another factor equals 0. And that's in particular to quadratic equations. If you had cubic equations, then you have 3 factors, so on and so forth, if it's factorable in the first place. But we'll explore those possibilities. Let me give one more example before moving on to showing quadratic equations in the trinomial form first and then factoring it, and several other types of examples. One more example of this zero product property that we're going to be using throughout. Suppose I had x plus 5 times x minus 3 equals 0. Now we can ask ourselves simply also, what would make this factor 0? Well, I can see that if I had x equals negative 5, negative 5 plus 5 is 0, so x equal to negative 5 would be a solution to this equation. Also, in the other factor, I could say 3 would work. 3 minus 3 is 0. Therefore, 3 is also a solution to this equation. To take the additional steps, just to show all of what I'm doing, I could say x plus 5 is 0, or x minus 3 is 0. And this is a statement simply of the a equals 0 or b equals 0. Here's my a, there's my b. So solve both of those equations. And this is important actually to do as these things get a little bit more complex and it's hard to visualize the solution from the beginning. So knowing how to do this step is good. Solve both equations independently. This one, I'm going to subtract 5 here. Also from the other side. There we go. Okay, and that gives me x is equal to -5. I will solve the other equation by adding 3 to both sides. This gives me x is equal to 3, and we have two solutions, x equals to -5, x equal 3 are both solutions to this equation. Okay, let me move on from the zero product property stated simply into examples, further examples of using it in the context of quadratic equations.